All right, so let's take a look at this problem number 11. It's got the same directions as problems 9 and 10. They want us to rewrite this equation, have a circle, and rewrite it in standard form from that equation. And when it's in standard form, it'll be easy to identify the coordinates of the center, and it will also be easy to determine the length of the radius. So if we look at this, we want to get all of the variables on one side of the equation, the numbers on the other, and it's set up exactly like that. Now, this time, since it has both an x squared and an x term, I'm going to have to complete the square in order to get it standard form. So hopefully you remember how to do that. I have x squared minus 4x, and you take half of this linear term. Half of negative 4 is negative 2, but you square it. Negative 2 times a negative 2 is positive 4. So I'm going to add 4 to this equation. Now, to balance the equation, to not change the solution set, I need to add 4. I need to either subtract 4 on the left-hand side immediately or add 4 on the right-hand side, and it'll balance it out. So if I choose the later to add 4 to each side. Now, the reason that we chose half of the middle term and then to square it is I don't have to use an X method or use any tricks with factoring. I know that this trinomial, that this is a perfect square, that I can write this as a binomial squared. So I look at this squared and take the base, and I look here that then the middle term and half of negative 4 was negative 2. And so I know that if you take the time to square it out. Now, exponents don't distribute. It's not x squared minus 2 squared. If you did it in the form of a table or any organized way to apply the distributive property, which most time you guys just do it in your head, which is fine, because you have enough experience and practice to do that. You see that we get along this diagonal the negative 2x and negative 2x is negative 4x. And we've got x squared minus 4x plus 4, which is exactly what we started with. So now, if we rewrite the y squared and just think of it as y minus 0 squared, and here 1 plus 4 is 5. If I think of this as the square root of 5 squared, that when you square a radical, that radical goes away. So here's my circle that's in standard form. I can easily identify the center as 2, 0, and I can identify that the length of the radius is the square root of 5. Now I need a decimal approximation for, I know the square root of 5 is going to be a little bit bigger than 2. So if I jump to a calculator, say, and call it 2.2, if I go to graph this, and you have graph paper, so your graph is going to look much better than mine. If I go out, 2, 0, the center of the circle, which technically I put a point there for drawing. Technically, that's not a point on the circle. 2.2 is the length, so it's going a little bit to the left of the origin there. If I go 1, 2, and it's going a little bit there. So if I try to draw my circle, looks something like that, and it has a radius of approximately 2.2, which is square root 5. This is the x-axis, the y-axis. All right, so we've got our standard form, our center, and our radius. That's all they wanted. Hope that helps. Talk to you later.